of where we've gotten our name. One other thing I wanted to add is that if y'all have any questions throughout this presentation, go ahead and post them in the questions section, and I can answer them as they come up. But to get started, we'll kind of talk about some of the applications. Really, there's a pretty wide variety of applications for trunnion ball valves. They're very good for transmission and storage, gas processing, industrial applications, refining, so on and so forth. They open and close very quickly, so they're kind of ideal for emergency shutdown valves. And they're very reliable bubble-tight shutoff. So coupling those two things together makes them very good for natural gas applications, whether it be for pipeline gas or for gas processing plants, inside and outside the fence. It's also a full port design in most cases, which allows the line to be pigged, and it provides a low pressure drop because of that full port. It's essentially, when this valve's in the full open position, it's like having a straight run of pipe running through there. Now, I kind of want to compare it to some other valve types that y'all might see for shutdown type of applications. When you compare it to a gate valve might be lower cost, but overall you're going to see some other disadvantages to the gate valve. For starters, it's going to have a lower CV because a gate valve, typically your normal API gate valve is going to have a reduced port in it. It will not be a true through conduit gate unless you purchase an API 6D type of gate valve. So that's one thing. The next thing that you're going to have is a Class 4 shutoff, which is going to allow a significant amount more leakage past the seat than what a trunnion ball valve or any ball valve might have for that matter, which is Class 6 shutoff. You're also going to see higher torques whenever you're trying to automate a gate, and if you did just a linear actuator on it, the thrust is going to be significant as well. So what that means is that it's going to be more costly to automate a gate valve than it would be for a ball valve or trunnion ball valve. Now also, you'll see butterfly valves in shutdown and isolation applications. There's some pressure limitations with butterfly valves. Typically, you can only get up to Class 600 or so on butterfly valves. On a resilient seated butterfly, you're only going to be able to get up to 200 psi, and that's going to be your bubble tights. Your double offsets, maybe up to 600. Most people kind of live in the 150 and 300 pound range. And one of the big limitations for a butterfly valve is that you only have one seating surface. So as you begin to go into multiple cycles, you're going to start wearing that seat down, and that seating surface is all you're going to have. So once that fails, you're going to have leakage. Another big disadvantage of a butterfly valve is that you have a disc sitting in your flow path. So the C sub V, the flow of the valve, is going to be significantly less. Now moving on to plug valves, you start to have more size limitations. You're not going to be able to get into say a 36-inch line or things like that because of the plug. It's also going to have higher torques because as you try and tighten down and reduce any leakage that might be coming out of your packing, you're going to be wedging that plug into its seat pocket and ultimately driving your torques up. It makes it much more costly to automate this valve. And then, of course, a plug valve is not going to have a through conduit. It's going to have a kind of a V-notched sort of port, and that's going to give you significantly lower CV as well. One of the other disadvantages of using a plug valve is that it's going to be higher maintenance, so you're going to constantly need to lubricate the seats, so on and so forth, things like that. And so it kind of adds to a lot more work in that plug. Now, each of these valves that I've just discussed, I'm kind of pointing out some of the disadvantages that they have in comparison to a trunnion. They all have their niche markets that they do very well in. So We can talk about those further too if y'all have any questions about that. Now, moving on to what a trunnion is versus a floating, you know, with a ball valve you have floating designs and trunnion designs. And basically what a trunnion means is that you've anchored the ball both on the top where the stem is as well as on the bottom to minimize the ball from moving or eliminate the ball from moving within the body cavity. Whereas on a floating design, you don't have that bottom anchor, and so when you move into the closed position, the ball essentially floats. The benefit of this is that you're able to get into higher pressure and larger diameter piping. It ultimately will reduce the torque on the valve, and so you can use a smaller actuator. Now, one of the things that you'll see is that I have on here is that floating ball valves have higher torques. We'll kind of mention that here in a moment, but it also has pressure limitations and size limitations, and they're all kind of related with each other. Basically what happens is that on a floating design, whenever you pull it into the closed position, it allows the ball to float in the body cavity, and the upstream pressure pushes that ball into the downstream seat. Well, with that large amount of surface area and a large pressure pushing it on there, you're going to have a lot of force being put on that downstream seat. Ultimately, you can end up crushing the seat whenever you get into high pressures, as well as having an enormous amount of torque because of how much surface area is seeing your line pressure. Whenever you go to a trunnion design, since we've anchored the ball and it's not able to move, we actually have to do something different to get our seal. So what we do is we energize the upstream seat and push that into the ball. So it's not delivering near as much force on the ball. You're still getting your shutoff, but your torques aren't near as high as what they would be if you had a floating design in the same pressure and size. Here I wanted to show you an exploded view of a seat design for a typical trunnion. The lighter gray area where it says seat, that is what's commonly called out as like a 3/16 seat or a carbon steel with EMP seat, something like that. But really what's giving you your seal is the red right here that says seat insert. The 3/16 seat is really just a seat holder. So whenever you put pressure behind that, that 3/16 metal is able to hold that pressure and press the seat insert into the ball. You also notice that the seat has a spring behind it. That is for whenever you have a very low pressure on the valve. So you're still going to get shut off even at very low pressures. Typically the seat insert is made from a thermoplastic material, so that's something like maybe a Teflon. Usually it's going to be a reinforced Teflon, or maybe a nylon or PEEK or something like that. One of the other things about the seat on a trunnion ball valve is that because you're having media charge the seat, you have to have an O-ring seal to ensure that whenever it's in the closed position that you don't have anything leak out. So you'll notice that there's an O-ring right underneath the spring. But in the case of a fire, we've also put in a graphite seal to back that up as well. So what will end up happening is that when you have a fire and your soft goods burn out, you have that graphite seal backing it up. Now, with a floating design, you're not going to have quite an intricate setup on your seat. So normally you can just have graphite body seals and then you're all good. But you notice that we had to do some other things to kind of help prevent this valve from having any sort of leakage since we're charging it on the upstream side. You also notice that the ball makes a metal-to-metal contact on the seat itself now. So once my seat insert has burned out, I now have a metal-to-metal contact to get my shutoff for API 607. Now, the next thing that I want to talk about on the seat design is that most trunnion valves are going to have what's called a single piston effect seat. This is also known as a self-relieving seat. But basically what single piston effect means is that whenever your upstream pressure comes in, it'll press that seat into the ball. Now you'll notice that there's some arrows coming off of the ball. That is representing the pressure that is pushing the seat back into its seat pocket. Because of the amount of surface area, you're not going to be able to push that seat back based on your upstream or downstream pressure. And so that's how you ultimately get your seal. But what will end up happening is that whenever your body cavity builds up pressure, so let's say it's a natural gas type of application, that the gas may expand due to thermal expansion, and so therefore your pressure increases. Well, as that pressure increases, it's going to push that seat back to help it relieve, essentially burping the pressure out of the body cavity. Ultimately, it's helping. This is a design. This was an intentional design that we had, or that any trunnion manufacturer may have, to prevent compromising the body cavity and possibly getting a leak out of the body cavity because you allowed it to expand too much. Now, there's also what's known as a double piston effect seat. It functions the same way as your single piston effect seat may, that as pressure rises in your upstream or downstream, it's going to press the seat into the ball, and that pressure can't push that seat back. But as pressure rises inside the body cavity, it will not allow the seat to self-relieve. You notice that the arrows and the surface area that you have in the seat pocket are going to be hitting a much larger surface area than what you see on the internal side of the body cavity. Now, the same problem still exists, that if you have natural gas and there's thermal expansion, you can compromise the body itself. So what we do, and when I say we, most trunnion manufacturers, is that we will drill and tap into the body and have a relief valve so that as that pressure builds up to, let's say it's a pipeline, so it's class 600 that you want to have it. So at 1480 or 1500 pounds, that relief valve will relieve out that pressure. And of course, you don't want to have natural gas going into atmosphere, so you'll usually have it relieve into a bottle or something like that. The main reason for double piston effect was to be able to charge both your upstream and your downstream seat. And by doing that, you're getting a redundant seat on the valve. So instead of just on a self-relieving seat, you're going to be able to just charge your upstream seat and seal there. Well, now you're able to seal on both and get what's known as double isolation and bleed. Whereas a standard single piston effect seat would be known as double block and bleed. Double isolation and bleed basically is calling out that that you're able to seal on both ends and bleed out of the body. Now, OSHA and API 60 both kind of have their own terminology for what double block and bleed means. You'll notice in the bottom right corner you have two valves in series with single piston effect seats. Those two valves in series, if you just took one of them and bled out the bottom, your upstream and your downstream pressure would press those seats into the ball, and you would have what's called a double block and bleed per API 60 standards. However, the OSHA standard is that they want to have two ball valves actually doing a redundant seal. So whenever this comes up in specs, a lot of times we have to start asking a lot of questions to ensure that we get you exactly what you want. What you'll notice is that the 2 valves in series don't offer you any more additional sealing than what 1 valve with double piston effect seats give you in the same type of application. So you can save a lot more money if you're able to go with like an API 6D standard and use double piston effect seats. A lot of pipeline gas guys will want a double piston effect seat in their valves to kind of get that redundant sealing. Another thing that we have here is that the emergency sealant injection. Most manufacturers will have this as an option so that you can inject sealant into the seat in the case that maybe your seat has stopped holding pressure. Usually this is because maybe you had sand in the line and you cut the seat or something like that. So in an emergency situation, if you had to shut the valve down, you would be able to pump a sealant in there and get your shut off. Now, our valves do not need regular sealants or lubricants to make them function properly. This is strictly for an emergency situation where you've shut down and you're not getting a seal because of some other means that might have damaged that seat. So you'll notice here where the red is coming in, that's exactly the channel that your sealant will go through, and it will seal or help seal that plastic seat. Now the same thing goes for the stem. A lot of manufacturers will have this as well, where it's just a sealant injection port for the stem where maybe you have a leakage through your packing, and you just do essentially the same thing. Now, the anti-static device, a lot of people are familiar with this term. Basically what it is that it's just the ball and the stem are basically sitting on O-rings and plastic devices where maybe it can ultimately build up a static charge. So what we have here is a ball bearing that's spring-loaded to basically create a ground between the ball stem and body so that you don't have any static buildup and ultimately have a charge ignite your gas line. Now moving on here, you'll notice that we have 4 basic different types of trunnion body designs. You have the side entry design, which can come in a 2-piece body or a 3-piece body. You also have top entry and then a fully welded body. The 2-piece side entry is essentially this. It's a cast steel design in most cases, and whenever you need to do any repairs, you pull it out of line and you unbolt the end and you're able to pull out the trim, the ball, the stem, and everything like that through the side of the valve. This is probably the most economical version of a trunnion design. A 3-piece design is typically forged. The same goes for this valve, is that you'll pull it out of line and you're able to do all of your trim change of the ball and the seats and stem through the side of the valve as well. The first major difference that you'll see in design is really with the top entry. A top entry valve allows you to keep the valve in line, and you can unbolt that bonnet on the top of the valve and change out your trim without ever having to pull the valve out of the pipeline. So there's some benefits to this if you're dealing with a very large valve and you need to kind of just change some O-rings or packing or things like that. There's also what's known as a welded body. This means that every seam is welded. You have no leak pads. The benefit of this is that you're able to put it in buried service and tend to forget about it so long as it's still functioning well. A lot of times whenever you go into buried service, you'll need to have an extended bonnet on it, and there's some things that you can do with that where you're able to still put injections into the seats or into the packing set and things like that, so that you can kind of do what you need, the normal maintenance that you may need to do on the valve. And I'll show you all an image of that here in a little while. Beyond that, you have essentially 3 different types of end connections. The most common is typically raised face flanged. There's also ring type joint, which is also known as RTJ, and then butt weld end. A raised face is essentially how it sounds. You raise the flange face up so that you can put a gasket there, and it's usually serrated. Whenever you go to an RTJ, we have that same raised face, but we cut a groove in there. And that groove, you will put in what's known as a ring gasket. And it's typically a soft metal, and it's a ring that whenever you push the 2 flanges together, so the mating flange to the RTJ will look just like this, and as you tighten the bolts up around it, it will essentially just smash that softer metal in that groove, giving you a tighter seal. Now with raised face flanges, you typically see pressures up to anywhere 150 up to 600. When you start getting into higher pressures, it becomes more necessary to go with an RTJ. And that's typically going to be your 6, 9s, 15s, and 2,500 pounds, 4,500 pounds, because it holds a lot more pressure than your typical spiral wound gasket. There's also your butt weld connection, and typically what we need to know with this is pipe ID, wall thickness and schedule, the pipe material, so that we can make sure that we do the appropriate bevel for you. All that information we take into and do a calculation and give you a correct bevel so you can get full penetration on the weld. Now this is just kind of standard features that you'll see with a lot of soft-seated design ball valves or trunnion ball valves. The blowout-proof stem, which essentially means that the stem is designed so that as pressure rises, the stem cannot fire out the top of the valve. The ISO 5211 top works. That means that it makes it easy to automate with an actuator. Anti-static device, like we spoke about. Emergency sealant injection, which we spoke about. Your self-relieving seats is your standard, so if you need double piston effect seats, that's going to be an optional design, and most people are going to be doing a factory lead time on that. A lot of people have a vent valve in the body of the valve, as well as a drain plug. The stem will have a 90-degree travel stop. Most trunnion valves are NACE and FIRESAFE, and that's primarily because their main service is going to be for natural gas. Now, we're used a lot in crude and refineries and things like that, but the main service is going to be a natural gas service. Now, most people will do a nickel-plated trim, so EMP means electroless nickel plating. You see some guys out there with 1 mil EMP, but those can tend to flake and chip. We went with 3 mil EMP to help defend against that, but somewhere along there you're going to have some sort of nickel plating as your standard trim, and then most will have gears. And ours, we wanted to make sure that we had a locking device for it. Standard trims that you're going to see, these are going to be carbon steel, stainless steel valves. You're going to have a 316 ball, carbon steel with EMP ball, something like that. Your stems you may see anywhere from 17.4 to 4140s, 316s, and A105s and things like that. You see the 17.4s and XM19s whenever you have higher torques or higher pressures on the valve. And then every now and then you might see an F51 or something like that. Soft goods, like I was mentioning earlier, RTFE seats, Devlon seats, Peak, FKM for your body seals, which is also Viton, HMBR, basically a type of Buna. Those are going to be your standard body seals. A lot of times you can get CalRes and things like that if you really need to get into something a little bit more unique. But for the most part, these are going to be your standards. HMBR is typically used for lower temp applications, whereas Viton, the FKM, is going to be used for higher temp. Most people will standardize on one of the two. I believe we're standardizing on Viton, but either way, most manufacturers should have some sort of versatility there. Now you'll notice that it says AED under HMBR AED and then FKM AED. Whenever somebody's calling that out, they're saying anti-explosive decompression. Basically what happens is that when a valve is in service, especially with natural gas, as pressure is applied to that O-ring, on a microscopic level, the gas is permeating that O-ring somewhat. And whenever the pressure drops quickly, what will end up happening is that gas will want to expand quickly, and it will burst the O-ring from the inside out. It's very much like popcorning that you might see in some Teflons and things like that. So what we do is we make the O-ring in such a way, and it might be cured such that it's resistant to that decompression, that explosive decompression. So some manufacturers might just have it designed to that, but if you want to really ensure that you're getting an O-ring that's been built for it and tested to it, there are certifications that you can ask for. So even with us, you know, we have certifications for our AED O-rings. So if you ever need something like that, we can help you out with those. Now, one thing we haven't discussed yet is that you have metal-seated trunnion ball valves as well. This is very different from what we were talking about before, and a lot of times it can kind of get confused because when somebody calls out a 3/16 seat, like we were discussing earlier, you're not really going to have a 3/16 ball with a 3/16 seat where they're touching each other, because ultimately those 3/16 is soft metal and it'll gall up. So metal seated valves are going to be designed a little bit more robust. They're going to be for higher temperature, abrasion resistant applications. It's a very hard surface, very corrosion resistant. And because of that, you know, we get some higher torque, so a lot of times you'll see a spline shaft to kind of spread the load on that stem and kind of deal with that. So here's kind of a cutaway of what a metal seated valve looks like. You'll notice the light green or teal that's highlighted there. That is the overlay on the seat. No longer is it a soft seat valve. This is an actual overlay on a 3/16 seat. So that might be a tungsten carbide, a stellite, chrome carbide, something like that. Now you notice the red color that goes around the ball. The ball is going to be coated as well, whether that be with a hard chrome, tungsten carbide, or chrome carbide. It's usually one of those three kind of components and combinations. With a hard chrome, it's just a plating, and the stellite is an overlay. But whenever you get into tungsten carbide or a chrome carbide, there's a process known as HVOF. It's a high-velocity oxygen fuel process that essentially fusion bonds the two metals together. So your 3/16 now has a significantly stronger bond with that tungsten carbide or with the chrome carbide. So it gets you into a lot more challenging applications. So whether it be a large diameter or a high pressure line or high temp, or very abrasive, this is going to kind of be where we go with the process of how we apply that coating onto the valve. Basically what will happen is that as you get into, let's say it's a 20-inch class 600 ball valve that needs to be metal seated. Well, there's so much force pushing that seat into the ball that if you had just had plating, that stellite will act as a knife and chip that plating away. So HVOF becomes very, very good for larger diameter as well. So moving on to the body seals. On a metal seated valve, everything's going to be a graphite type of seal. So the body seal you'll see here is a spiral wound gasket. As pressure rises, it will expand and press out even tighter, ultimately giving you a seal there. You have a graphite seal behind the seat pocket, similar to like what we had on our FIRESAFE soft-seated valve. And then the packing will all be graphite. So what this ultimately means is that there's no plastics or O-rings inside of this valve. It's inherently fire-safe on its own. Now, with the fact that it is inherently fire-safe, we went ahead and got it tested, and the test for a metal-seated fire-safe valve is API 6FA. So we do have the certification for that, as most other metal-seated Trunnion guys might as well. Typical materials that you'll see on this: carbon steel, stainless steel, duplex. We were mentioning the hard chrome, tungsten carbide or chrome carbide, basically overlaying on the ball and seat. And your temp range can be anywhere from -320 to essentially 1,000 degrees Fahrenheit. One of the other things too is that you'll notice that like your hard chrome and stellite, these are for some of your applications that just might be a little bit out of the reach of what your soft-seated valves can do. So 600 degrees, something like that you might have in a hot oil application, you should be fine using a hard chrome with stellite. But if you're getting abrasives involved, so let's say that you're working with a coker unit, you're going to probably want to move to a tungsten carbide. You'll notice that the hardness on this becomes significantly more. It's excellent for a much higher temperature, so you're getting into 900 degrees now. And then if you go to a chrome carbide, this is primarily going to be for very hot applications. So you'll notice that it says 1,600 degrees Fahrenheit on the chrome carbide, and the slide before said 932 degrees. That limitation is because of the body material. So if you need to start getting into special body materials like a chrome moly, things like that, then you're going to start stepping outside of the standard offerings, and you're going to have a factory lead. But we can help you achieve those types of applications. You'll notice that the standard designs are very similar to what a soft-seated valve has. Single piston effect seat, so it still functions the same, where you're going to have a self-relieving seat. It's going to be fire safe, of course, like we mentioned, your blowout-proof stem, ISO 5211 TopWorks, anti-static devices, things like that. Now, what you will notice, though, is that NACE becomes an option now, because temperature will restrict based on the bolting. So your NACE bolting might not be able to hit the temperatures of what you're looking for. Live loaded packing is something also that we can offer as an option here. That's an option that we offer on our soft-seated as well. Basically, if you're unaware of what live loaded packing is, it's two Belleville washers that lay on top of each other and cup each other, and when you tighten them down, they act as a spring, and so that spring maintains pressure on the packing set of the ball valve throughout pressure increases and drops. So whenever pressure increases and then it drops off, your packing doesn't just get loose and then allow leakage through the stem. So those are some options that we can do. This is just an image of what a splined connection looks like on a ball valve. Notice that it's not just like your standard double D stem or square stem shaft design. It actually is splined so that it can get more surface area and spread the load across the stem. A lot of the certifications that you'll see for Trunnion ball valves are going to be like your API 607, API 6FA. Those are both fire safe standards. API 6D is a pipeline standard. Our valves, for instance, are built to API 6D as well as B1634. The testing standards that we have are API 6D and API 598. The ISO 9001 is a certification we have as well, and you'll notice that the check marks basically are what we have currently. CEPED is a standard that we just got, or certification we just got, and we're working on our TA lift. So our fugitive emissions packing should be coming in soon. Some of the options that you can see with a Trunnion valve is going to have extended bonnets. You can even get a reduced port. So you might eliminate your ability to pig the line, but you can kind of save quite a bit of money if you use a reduced port valve. A lot of the money when building these things is tied up in that ball and stem set, because there's so much stainless steel there that you might have. Live loading again, spool piece mounting kits, factory testing, things like that. This is an example of what an extended bonnet looks like. We were mentioning it earlier for buried service, that you can get an extended bonnet and still be able to inject into your seat injection points, like your emergency seal shutoffs, and your packing injection. So there's some things that we can do to kind of help out with that as well. You can also have transition spool pieces done on these things. Really, you can get quite custom with a trunnion valve. Now, just kind of transition this into what you might see in the field. Having an automated trunnion ball valve is pretty common because they are emergency shutoff valves. This particular one here, you'll notice, has a spool piece underneath its declutchable gear override, and then it's a double-acting actuator on top. Having that spool piece was essentially to extend the stem out so that it could get clear of scaffolding on this one. But the declutchable gear override is just a manual override option. There's some pretty unique things that you can do with these things. Different automation types are going to be your pneumatic, hydraulic, electrics, and electrohydraulics, and even gears, for instance. Pneumatic is probably the most common. It's ideal for shutdown valves, which is what these valves typically are seeing. With that, one of the disadvantages of using pneumatic is that you require plant air for most cases. There's a lot of torque output that is delivered with a pneumatic actuator, typically Scotch yoke actuators or rack and pinion actuators, and you can kind of build a custom package however you see fit. So whether that be a partial stroke system, or if you need to have high-low sensors put on there for it to shut down if you start losing a little bit of plant air, things like that, you can get pretty custom on the pneumatic side. So the accessories can kind of be limitless, whether it's solenoid valves, pilot valves, limb switches, positioners, so on and so forth. Now, hydraulic is going to essentially function the same way, but instead of using 80 pounds of air supply, now you're going to be using high-pressure hydraulic oil. And the hydraulic oil will be somewhere in the 2,000, 3,000 PSI range. Since you have so much more pressure being delivered to your actuator, you can minimize the actuator size. Now, the reason why I bring that up is that in a lot of cases for pipeline gas, well, they don't have plant air and they don't have power. So what they'll do is what's called a gas over oil hydraulic actuator. So the valve will be out in a remote location and it will be drawing 1480 off of the pipeline, and there will be a series of bottles where you transition that natural gas into a hydraulic power, and then the hydraulic fluid will push that actuator into its open position. And then as pressure starts to drop in the pipeline, then it will switch over and the spring will slam the valve shut. So hydraulic actuators have a very good place in this as well. Now, a lot of times you don't have any power. You can't really do a gas over oil, or not necessarily any power, but you don't have any air, but you may have power. So people will go to an electric actuator. These tend to be a little bit more slower acting, which can be good for water hammer, for liquid lines. You're not going to slam it shut and then have a lot of disruption in the pipeline. Fail-safe tends to become a challenge because you're either going to have to do a battery backup or some sort of spring-loaded cam scenario with the electric actuator. And it really limits the amount of torque that you can deliver whenever you go fail-safe. So you can usually have these in a fail-last position, and they work just fine for trunnion valves. Very good for areas where there's no air available, and you'll notice that 12 volt, 24 volt, all the way up to 480 volt three-phase electrics are going to be used to automate these things. One of the benefits is that most electric actuators are going to have limit switches built inside, as well as a manual override. So a lot of those accessories on a pneumatic that you're having to build your package, well, they all kind of come in one housing unit with an electric actuator. And then you get an electrohydraulic, which kind of helps overcome some of those challenges that an electric has. It's basically an electric actuator and a hydraulic actuator working in tandem to kind of help give you some fail-safe options. Lastly, you're going to have a gear or a wrench actuator. or just gear off or wrench off is what many people will call it. This is primarily used for like a bypass line or an isolation valve for control valves or other equipment. These valves are typically out there just for the day that you may need to do some sort of maintenance for or something like that. It's not going to be an emergency shutdown valve. So to kind of review everything, trunnion valves are utilized in a ton of different industries and applications. It's mostly because they're a large diameter option to give you one of the best sealing capabilities that you can get out of a valve. They're very good for high pressure. They're ideal emergency shutdown valves. They offer reliable bubble-tight shutoff, and they're great for gas applications. The design is that it's a pickable design, and they're pretty easy to automate. And the last thing that I had is, does anybody have any questions to talk about our offering here? Okay, with that, I'll turn it over to Alyssa, and she can let you guys know.
We are going to, we do have a question.
Oh.
To clarify, are these API 6D valves?
Yes, these are API 6D valves. They're an API 6D valve. It's API 6D certified. And if you need copies of the monograms or things like that, y'all can contact us on that.
Next question is, what are the valve testing standards?
The testing standards that we abide by are API 6D and API 598. And API 6D actually utilizes API 598 quite a bit.
More minutes. We will have this another question. What are the differences between a 2-piece versus a 3-piece ball valve? And in what circumstances would you use a 2-piece versus a 3-piece?
The 2-piece is a much more cost-effective option. Tend to use them a little bit more on lower pressure lines like class 150 or class 300 pressure. When you start getting into higher pressures, a lot of people tend to like to get into a 3-piece forged design just because the forging is just a truer, more dense metal. So that tends to be what you see in the differences of the design. Now, the cost difference is that a forging is going to cost a little bit more than what you might have with a casting. So a 3-piece design, because it's using forgings, is going to be a little bit more expensive.
We're also going to post this to our Relevant Solutions YouTube channel along with the previous webinars that we've done. I will send out a link with that, as well as those who need hours of certifications for certain products. We will have certificates for you available within the next couple of days. And if you guys have any other questions, please reach out to me. I can also get you Doug's Manning's information, as well as any other product information that you're looking for. We thank you very much for joining this webinar. We hope to hear from you soon.